So we are going to draw here. Ne? So as you can see, we do not have the magnitude of the reactions. So according to the question, we were supposed to calculate the reaction first. But for the sake of this lesson, we are not going to calculate the reactions. We will measure them at the end, because we do have a starting point. How many points do we have here? 4. So I will name them 1, 2, 3, and 4. So what will be our starting point? Sorry? Point 3 will be our starting point. So point 3, we have a force going down as 22 kilonewton. Also this one, as well as this one. Here is B, C, and F. At least we know that BC is vertically downwards, right? At what angle is FB? At what angle? 30. Do you all get 30? Who does not get 30? Marshall. Eh? Angle yela telling like. Don't have call on all. So okay, how do we get this angle here?
Yeah, so we have 90 degrees.
Eh?
With a triangle there is 90.
90,
And the side.
the side.
Yes. So
We have 30, we have 120, and we have what? 40 here. 30. 30. 120, then 150, then 30. So, it's either now we find this angle here, it's either we find this angle here, or we find this angle here. Remember, when we measure, we need to measure from vertical or horizontal axis. So which one which one can we get? This one or this one? This one. And what is the magnitude of this? It's 30, ne? This one here, it will be 30. And what about this one? If we were to calculate this, it's 30, ne? This one is 30. If you check this one, alternate with this one, right? Yes. And this one, if we were to find this one, you have that you can construct a triangle here, which this one it will be 60, therefore that one is 30. So in here we are having 30, 30, and 30 in that direction. So now we can start drawing. So which one do we start with? BC. BC going down. When you draw, you must also consider the place where you are going to draw. If your drawing will fit, your vector diagram will fit. So calculate your vector diagram before you can start drawing. So this one, it has the downwards arrow. What is this point here? B, and this one? C. So after drawing BC, which one do we draw now? CF. At what angle? Angle 32 to the horizontal or to the vertical? To the vertical? Yes. So agree, this one is 30 degrees from there to there. Ne? So even here at this point, need to have a small Cartesian plane measuring 30 from there to there. Somewhere this side or somewhere going to this side, we have F. Even that side we also have F. I guess you are busy drawing because at the end, we need to measure. And make sure that your vertical lines are vertical. Horizontal lines are easy because you measure them against the book lines. So, you're done drawing, ne? So now we are going to draw which one? FP. FP at which angle? 30. 30 to the horizontal or 30 to the vertical? 30 to the horizontal, ne? So here is still our small Cartesian plane, 30 to the horizontal, meaning we measure from top going down. So you will take the protractor at which point? We are drawing B, FP. So at which point? Sorry, at point? At point B, ne? So here at B, I have a small Cartesian plane because I'm going to draw FB. I do not have F, I only have B. So at point B, I will have my small Cartesian plane, and this line is 30 degrees from horizontal. Therefore, I will measure 30 degrees. I am so 30. And this one is 30 from this one. So this one, it will go something like this. Right? And this one, 30 is from there, it will go something like this. It's correct, ne? So they intersect here. So this one is our point F, because somewhere this side we're having F, and somewhere this side we're having F. Therefore, this point is our point F. So which one do we draw now? The point. Which point are we going to choose? Point 2, ne? Are we done with point 1? Are we done with point 1? What is left? Arrows. So we're having this arrow going down. And what about the arrow at CF? Up. The arrow at FB. Yeah, pants. Yes, that like that. So we take this arrow out. From there, we can now go to the next point, which is closer to that one. So our next point is point 2 and point 4. So we choose point 2 because point 2 at least it has 1 noon. So this is 42 kilonewton. B F E A. So which member do we start with in this case? Sorry? AB, ne? So I must be able to connect this one to this, right? You say I'm drawing AB. Do I already have, is either A or B on there? Lecture diagram. So which point do I have B, right? Yes. So I want to know, is B, I already have B. Is A somewhere above or somewhere down? B is above. Because this one is going down and this one is BA, therefore BA, right? Oh, this one is AB. It's AB. AB. So it's also vertically up with downward arrow. So this one here is A. You need to draw using your own scale. The bigger the scale, it won't fit in your book. The smaller the scale, so what is this angle here? What's the angle there? Sorry? 120. And this angle here, remember we need to draw, is either we have a vertical line or a horizontal line. Eh? So the angle which we place here, let us place the one is either vertical or horizontal. So I can put my small Cartesian plane there and another one there. So that the angle which we place, you understand, eh? So here, what is the angle here? It's what? 30 and this one? 60, this one? 60, this one? 30 and this one? 30. Okay. So now, which member are we drawing now? Which member? BF. We're going to draw BF because we're moving clockwise, right? BF. We already have point B. Even we already have F, ne? So it means this one has already been drawn. We go to the next one. The next one is FE. We don't have FE there, right? So FE is at angle, which angle? 30 or 60, depending Do you measure from horizontal line or do you measure from vertical line? Do you get that part? Ne? You don't get this one. I agree. When you measure the angle, you must always use a Cartesian plane. So from the Cartesian plane, we have the horizontal and vertical line. If here is your F, here is the line which you need to draw. It's either you measure from this vertical going that side, or you measure from this horizontal going down. So when you measure from horizontal, it will be 30. When you measure from vertical, it will be 60. So depending which you are, depending on your reference. So in this case, which reference do we use? Horizontal. So we need to draw FE. We should have one point in there. So the point which we have is F. So at point F, we have our small Cartesian plane. Then if you say we measure from horizontal, we'll measure 30, as here is also 30. We measure 30, then we'll draw a line, which it goes like this way and this other way. So somewhere this side we have E, and somewhere this other side we have E. So the next one is what? EA, right? EA. EA is at angle what? Angle 62, horizontal or vertical? Vertical. I agree here is vertical line. So it means we're going to measure from vertical to where it is 60 to horizontal. This one here is horizontal. We're going to measure 30. So now here we have A, we have our small Cartesian plane at A, then we measure 60 from vertical going that side, or 30 from horizontal going that side, as there. So this, they intersect somewhere there. So here is where there is our point E. This one here is where there is our point E. Like that. So now we have drawn point 2. The only thing that remains are the arrows. So the arrows we have A, B. From there is B, F, meaning BF is going up. What is BF? BF here is going up. Then is FE. FE is also going up. FE. Then is EA. EA is also going up as well. Yes. So in that case, I can take this arrow out. So which point do we choose now? Which point? Point 4, point 2. Which one? Point 2, no, point 2 I have already drawn. Now it's either we take this one or this one, as long as it's closer to this one. So which one do we take? Point 1. Okay. Point 1, we have This going to that side, horizontal, vertical. 30, A, D, and E. So we're going to draw that point. Remember, we do not know the magnitude of the reaction. We did not calculate the magnitude of the reaction. So, okay. Which one do we start with here? Which one do we start with? Let us start with DA. Reason being, DA, it has a direction. Although we do not know the magnitude, but at least it has a direction. So, if this one is DA, which point is A? On top is A, ne? At the bottom is D, right? So at the bottom, we cannot be exactly know the point, but we know that somewhere down we have D. Because we do not know how long it is. But because of the arrow, we know that somewhere down we have what? D. So here we are having point A. Here we have point A. Then somewhere down, where we do not know, we have point D. So okay, now we're going to draw what? EA. Sorry? AE, ne? AE is already there. So from there, we draw what? ED. And ED is horizontal, right? And we already have point what? Point E. So at point E, I'll draw a horizontal line. I do not know this side or that side, right? But it's obvious because somewhere here I have D. It means this point here is our point D. So now, following the arrow of AD is going up, AE is going down, AE is going down, then ED is going that side. So if you check, even this point is already out. The only thing which remains is to finish the arrows. So the arrow here, in which direction? Here, for this member. Down. For this one? To the? Right. To the right?
To the left.
To the left. And this one? Down. So, we are done drawing. So this one is your vector diagram. So now, we want to find the members. Let us see. This reaction, the reaction on the left, is AD, ne? Is DA, this reaction, right? Yes. So meaning you need to measure DA or AD. This time does not matter because we're no longer drawing which one we start with. What will be the magnitude here? What do you get when you measure? You get exactly 10. 10,4. 10,4 kilonewton. It was 11. 11 kilonewton. Someone?
10.
Exactly 10 kilonewton. Those who got 10, it means you are good in measurements. Even your lines where you were supposed to draw it vertically, it was vertical. When you're supposed to measure 30, you're measuring 30. But this doesn't mean the one who got 11 is wrong. If you got 11, it's still correct. Because 11 is not far from 10. Even if you got 9, it's still correct.
But if you got 8.
If you were having 100 kilonewton, then you get 98, that would be correct. Yeah. I'm trying to say it depends on the value of the angle, the magnitude. Yes. So that is your reaction. Those who calculated, they said they got 10. And when you measure, you get 10, continue getting 10. So what will be the reaction on the right? Reaction on the right is represented by which member? CD, ne? CD is equal to how long?
64 minus 10.
You need to measure. You need to measure. Give 54. You got exactly 54?
Yes.
Sure. Yeah, good. And then AE, what did you get for AE? AE. Agree, this is a member, this one. Sorry? Yeah. This is a member, this is a member, the member, the member, the member. What did you get for AE? 20. 17.5.
15.
Kilonewton and 15 kilonewton, 20 kilonewton, 19.5.
Yeah.
19.5 kilonewton. Kilonewton. Then the nature. Nature.
Of what?
AE.
Start.
Strat. Because this AE, because the arrows are opposing each other. So meaning if you do not draw those arrows, you won't be able to get the nature. So in the book they got 19.5 strat for AE, meaning those who got 20, they are still correct. Those who got 17.5, yeah. But 15. 50, can you please reconsider? When you draw, just try to make sure that your ruler is vertical. Because in most you struggle with a vertical line. If you want to draw a vertical line, just take a protractor, you put on a horizontal line, then you measure 90. Then vertical will come. Yes. Because horizontal lines are already there in your book. So let us check. But I trust that you were getting it right. BF, what did you get for BF? For BF? BF? 26. You all got 26. 23. 35. 24. Yeah, there is 22.5. So 20 is 26 little bit out. Masha, we need to consider drawing your lines exactly vertical. Also check your measurements. So reaction does not have nature, ne? Reaction does not have nature. So the last thing is to calculate reaction. we should calculate the reaction. Was this one you said you did manage to calculate the reaction, eh? And you got 10. So I want to see if we can also do the same on this one. Number 13. Yeah. Oh, I do not talk about the shoot here. 3 kilonewton. 3 kilonewton. On this drawing, let's take for instance, we were not given this measurement. Ne? If we were not given those distances, and they need to calculate reaction. So you should consider the units for special triangles. For instance, if you have, there's 90, there's 60, there's 30. What is the opposite of 30?
1.
Is 1. Opposite of 60? Root? Is it not root 3? And here is 2. So, if ever you were not given a measurement, it means the distance from there to there, we consider it as root 3. Ne? The one we will consider it 1. For instance, here we are having 60, it means there is 30. So if we were not given from there to there is 20, it means for the fact that this is 30, here we're going to use 1 from there. And this side we're going to use root 3 according to that one. But in this case, we are given dimensions. So let us take a moment about the right. This side is the L. We need to calculate the reaction at L, which that one is more simpler. So when we talk moment about R, about R, sum of clockwise moment is equal to sum of anti-clockwise moment. So when we are at R, which forces will push our beam clockwise? is L, ne? So it will be L multiplied by the distance from where we are taking moment up until there, ne? It's L times the perpendicular distance up until there, which it will be 8, ne? Is that the only force? Is there any other force that push clockwise? What is the other one that push clockwise? Ayikho, ne? Equals 2. The one that push anti-clockwise? 3 times 60, 70. Okay, let us do like this one. Which force is this one? Eh? Let us use this 3. Is what? Remember I said you use perpendicular distance. If I'm here I'm having the force. You need to use the perpendicular distance to this force. Which is what? Where did you get that 40? $34.65. This distance here is perpendicular to this force. So you cannot use you only use a perpendicular distance. You get that part, ne? Yes. Yes. So plus another one, 3 times 60,3. So what will be the magnitude of L? Sorry? 3,898.